So, hey, I'm Alex Otto of OSW Audio. We're based out of Tempe, Arizona. We design and commission and provide calibrations for private screening rooms, recording studios, Dolby Atmos production rooms, two-channel hi-fi rooms, anything audio specific and centric, we're focused there. So, upon visiting the site for the first time, and in full disclosure, I did get to design the room, so I had a fairly high expectations of what we could achieve in the space because we had engineered it from the beginning. So we didn't. I wasn't walking in cold, and oftentimes, quite frankly, oftentimes I am. So if I'm providing a calibration solely for a client, it was perhaps designed by somebody else. Not sure what I'm walking into. You're going to have as you walk around in a space, and if you do this work enough, you're listening quite closely to how the room is behaving just to your spoken voice and just walking around and having normal conversation and engagement. This room, right out of the box, walking in, was quite good. I was quite happy with how everything had turned out. Now, of course, all of this, we go through a lot of engineering and modeling and do our best effort to have some kind of predictable result. But then, of course, you're going to involve construction and materials vary, and there's other variables that we're not able to account for. And gratefully, this room was solid. The builder was a pleasure to work with. They were conscientious. They were following up with us. They were making sure that they were doing the best execution possible, so we could deliver the client the best end result. So, in all fairness, I had pretty high high expectations coming in because we did get to work on it from the onset. And gratefully, upon walking in for the first time, I was pleasantly surprised. I mean, every room's going to have challenges, and I'm sure you'll see this later in the video, but we have a wall of glass. That's always going to be a big challenge. Is this going to work out for us in the end? And of course, we're in a situation where it's we're not in a dedicated room. It's kind of I would say very high spec. I don't even want to call it a media room. It's such a beautiful high spec room, but it's not a dedicated cinema, right? So we're not a complete blackout. We didn't have complete freedom and flexibility to build the walls as deep as we needed to accommodate acoustic treatment. So we're always managing managing expectations and the compromises. There's always, no matter what we do, there's always going to be some factor of compromise. I mean, ideally, we wouldn't have to put doors in the room. They'd be a lot easier to to design and isolate, and that would solve a lot of problems. But we got to get people in and out of here, and so all of these. Gratefully, the room worked out quite well. Quite happy with this room. So, calibrations and when we're dealing with getting a room online, a lot of it's an iterative process, right? So we're going to make some adjustments, some do a lot of listening. And the difference between the first visit for the calibration and then and a revisit, and I do this oftentimes, we'll go back and revisit a room. Oftentimes with subwoofers, we need motors to break in. We need things their motors are mechanical parts. They're going to behave a little differently after they've been run in. And in all honesty, in this room, what changed significantly was I really had a much better understanding and appreciation of how to integrate the hard subs that are present in this room, the four 18-inch subwoofers. On the first go around, I can say full stop, I didn't understand the full potential that was available in these custom subwoofers. So I think between spending some time with the owner of Hardbottle Audio, with Cody, getting a deeper understanding of what these were capable of providing, made me more comfortable in coming in and being able to push them and lean on them and understand really what the limits are with these subwoofers in this room. So that probably was the biggest, certainly the biggest change we made was in how the subwoofers were behaving and how they were integrated and handed off to the main loudspeakers. Anytime we put a loudspeaker in a room, we're going to have some anomalies, and especially as the rooms get smaller, right? As we get smaller and smaller, we're going to have modal resonances and ringing, and as you can imagine, anybody who's been around the block a couple times is going to go, yeah, it was probably the low end. Yeah, the mid-range and the high frequencies are quite easy to deal with, right? The wavelengths are really short. It's a lot easier to deal with 5 kilohertz than 5 hertz, than 5 cycles. That's a big problem. these resonances and ringing are all directly related to the dimensions of the room. So in this room in particular, yeah, we had, you know, this room, again, we're dealing with these compromises. I didn't get to build a 5-foot deep trap in the back of this room like I might do in a commercial recording studio, right? So Warm Audio, for example, out in Austin, Texas, that visibly, the back of the room is another almost 4 foot deep in trapping to deal with those modal resonances and ringing that get established in the room. Here we didn't have that luxury. Now we did get to build a pretty nice broadband trap that was probably good down to 100, maybe a little below 100 with the limited space we had. But 29 cycles fits this dimension front to back, the longest first order axial mode in the room, and that of course very easy. If it's a resonant frequency, that's where we have the most efficiency. You don't have to put a lot of energy in the room to get that imbalanced from everything else in the spectrum, right? We're targeting for balance across the entire spectrum. So, you know, 29 cycles. Well, how are we going to deal with it? Well, I can't make the room bigger. That's already baked in, right? So that's done. We can't fill the room full of traps. What are we going to do? We're going to leverage the power of placing multiple subwoofers throughout the room. And to be clear, the multiple subwoofer concept, like this isn't in lieu of any acoustic treatment. This is in conjunction with other acoustic treatment. I mean, there's no solution. And gratefully, most of the company, you know, any of the companies that are dealing with correction systems, they're never going to stand in front of a camera and tell you, "Yep, use a Trinnov, use a Storm. You don't have to do anything other than that." Of course, everyone understands we have to have some acoustic control and treatment in the room. And you start with a broadband approach, which we did here. The whole ceiling is a big broadband absorber. The front wall's got absorption, and even little things, you know, a couch is going to be a low frequency absorber. A lot of the you know, this resonance and this ringing, that's going to all manifest at the boundaries. The only thing that 50 cycles sees in the room is the walls, right? 50 cycles is going to see you in like whatever, right around you. It's going to manifest as high pressure on the boundaries of the room. And by placing the multiple subwoofers on opposite poles of the same room, we can manage and use some of this behavior and this understanding of that these are pressurization devices, and we use those multiple subwoofers to flatten some of that response. More importantly, the multiple subwoofers distributed around the room will allow us to fill in some of the holes. And if we have these resonances that are going to establish areas in the room where you have really high pressure and when you have nearly nothing, it's really instructive. And kids at home, if you want to go have fun in your room, turn on an 80 cycle sine wave and just walk around your room. And you'll be blown away where you're standing someplace, it completely disappears. Go stand in the corner, it's probably ripping your head off. Right? All of the modes terminate in the corners. We know this. And we've all experienced this, right? You're at a party, you're listening to the stereo, you go stand by the corner, you're like, wow, there's all the bottom end. So with the multiple subwoofers, and if we're thinking about them not only as a way to extend the low frequency output of the entire system, right? To take some of the load off of the main speakers, right? To provide more energy. Now, there's all these benefits to having subwoofers in the system to begin with, but if we place them in the right places, opposite ends of the room, for example, is quite common. We can use this destructive behavior, this constructive and destructive behavior to our advantage. And a way I like to think about this is if you think of a balloon, right, and you think of that balloon as your room, and on one end of the balloon, I'm going to squeeze on it. So I squeeze on the balloon, and the whole balloon instantaneously expands in all directions. The whole thing moves, right? You have this pressurization. It's almost like your chest, like you take a breath and everything, right? It's not a laser beam. It's not a light beam. It's not 5 kilohertz going, poof, right, like straight out of my face and you know, right towards you, right? The whole room is getting pressurized with a low end. Okay. Now, if I take another subwoofer and put it on the other side of the balloon, and I go and I squeeze at the same time, what happens? Well, now we get stasis. They're finding each other. That's really helpful. We're sitting in the middle of this, and where we had maybe a cancellation, they just went, they filled in. Now, The other thing to realize also is that we put the subwoofers in an area where they're in really high pressure. They're up against the boundary. So that 29 cycles is coming up also. But gratefully, we can use, for example, in the Harbottle audio subs, probably the most capable DSP I've ever seen on board on a subwoofer. I can get into that thing and I've got high pass filters, low pass filters, all pass filters, multiple bands of EQ, delay, polarity, invert, level, everything that you would find in a high-spec loudspeaker processor, like on a touring system, like in a drive rack in a touring system. It's on board on every one of those subwoofers with DSP. So we can go in and manage that, and I can create a filter that matches the resonance. And of course, that means taking high-resolution measurements with lots of microphones and making sure that we're grabbing the correct information, and we can just pull some of those down. The EQ works very effectively there on those resonances and ringing, because they're essentially in a small room. They're in high pressure everywhere, right? This 29 cycles, I walk around the room, it's like it's absolutely everywhere. Those wavelengths are really big. The room is small. That we're in a high pressure zone everywhere. Now, if I take that EQ and I'm at 8 kilohertz and I'm looking at one microphone, I probably need to be really careful about what I'm doing, because a little bitty move, a little bitty adjustment at 8 kilohertz is going to be very different as you move that microphone around the room. So this application of EQ down low in conjunction with the multiple subwoofers, getting the timing behavior correct so that the subs are playing as one unified system. Using equalization to temper those peaks, those inevitable peaks that we're going to get. But the good news is, what do we get? We got those holes to fill in, and that the only way you get that, and the most efficient and easiest way to get that, is to use multiple subwoofers. Most small rooms don't have enough room to afford you to place the monumental amount of passive acoustic devices it would take to improve the situation with multiple subs and some capable DSP to manage and tune the whole system. It's really the most efficient way to solve the problem. And something like, a very sophisticated subwoofer like a Harbottle, that's tons of clean output, really capable DSP, that just makes it easier to dial the system in. I have complete flexibility to dial the system in. It makes the handoff to the mains more transparent, so it just sounds like one system. I mean, the best integration with the subwoofers should not call attention to itself. If I turn them off, you should miss them when they're gone, but they shouldn't be barking, saying like, "Hey, I'm a subwoofer, I'm over here." It should be totally a seamless transition between those two, and you will miss them when they're gone, but they shouldn't be calling attention to themselves. I feel that's as a general starting point, that's where we would be. So that to the question of were there some issues in here still? Yeah, I mean, every room we're going to encounter this. We're going to try to model, we're going to try to sort it out beforehand, but undoubtedly going in, we know, and that's part of the calculus. Okay, we're going to put 4 subs in here. It's going to really enhance the experience, but we're also going to use it essentially as program dependent, program responsive, active acoustic treatment. I never think of the subs just as like, oh, it's this low end noise box thing to make your pants flap. Yeah, you get that. That's exciting, but it's really, when I'm designing these rooms, it's really a big consideration as part of the active component of an acoustic solution for the room.